Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about estimated time of arrival, commonly known as ETA. This topic is based on a tech blog with the title Improving ETAs with Multitask Models, Deep Learning, and Probabilistic Forecasts, written by the machine learning team from DoorDash. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now let's dive in. On the business side, let's take a look at the problem to be solved. DoorDash is a food delivery and logistic company that connects customers with their favorite local restaurants. As of July 2024, DoorDash takes over 67% of the market share for food delivery services in the United States, and it has a market capitalization of around $45 billion. The company's business model relies heavily on providing fast and reliable delivery services. This makes accurate estimated time of arrival, or ETA, crucial for its success. When a customer opens the mobile app, the ETA is displayed throughout the user journey, including the home page, the store page, and the checkout page. The home page and store pages usually provide an early expectation of the delivery time, and the checkout page offers a more detailed estimation or more accurate estimation of the time for delivery. These ETA estimation needs cover various delivery types as well, such as meal pickup directly from the restaurants and grocery orders, which requires in-store shopping services. DoorDash uses machine learning algorithms to predict the ETA for each delivery based on factors such as traffic, weather, and restaurant preparation time. By providing more accurate ETAs, DoorDash can set better expectations for customers about when they would get the food. This could improve the customer satisfaction and ultimately enhances user retention and profitability for the business. Now that we've understood the business problem to solve, let's shift gear and dive into the modeling side to see what could be a good solution. The machine learning algorithms that powers ETA predictions has been in place since the early days of DoorDash. Recently, the team made significant improvements to enhance the accuracy and reliability. There are three key directions for making those improvements. Let's examine them one by one. The first major change of improvements was transitioning from a tree-based modeling approach to a deep learning-based approach. Tree-based modelings, such as decision trees, random forest, and gradient boosting trees, they involve creating a series of decision rules to split the data into different branches. Ultimately, the combination of the branches can lead to making the right prediction. These models are beneficial because they are interpretable. They can also handle both numeric and categorical data, and they are relatively quick to train. However, the tree-based modeling can struggle with high-dimension data and often requires extensive feature engineering. The team also observed that the tree-based approach could not generalize effectively to unseen or rare use cases, and also they reached a performance plateau due to the lack of learning capability. In contrast, the deep learning-based architecture can leverage neural networks, which are more capable of learning intricate patterns and relationships within the data. This architecture can handle vast amounts of data and variables, automatically perform feature extractions, and adapt to complex and nonlinear relationships. This shift to deep learning architecture enables a more advanced modeling techniques to be applied and marks a foundational paradigm shift for future modeling improvements. The second major improvement was the introduction of multitask modeling. Previously, the team has to build dedicated models for each specific ETA use cases at the various entry points where user interacts with the platform. Gradually, the ETA model's numbers increases, and this proliferation of models leads to three major problems. The first problem is that managing the numerous models became increasingly complex. Each model required individual monitoring for reliability purposes, as well as make the right maintenance and updates. Any single improvements, such as introducing new feature sets or architecture changes, has to be independently applied to each model. As the number of models grew, so did the maintenance efforts. And this leads to inefficiencies and increased operational overhead. A second problem is that the independent training and learning of these models make it very inefficient. Many of the underlying factors affecting ETA predictions, such as traffic conditions, weather, and restaurant preparation times, are common across different use cases. If we train separate models for each scenario, that means the shared information was not being utilized effectively. This results in redundant competitions and a lack of synergy between models. And this fragmentation prevents the system from leveraging shared data insights and can reduce overall predictive accuracy and efficiency. The third problem about the proliferation of models is that the independence of prediction results from different models made it a challenge to maintain consistency. The discrepancies between predictions for different scenarios could rise, and this could lead to user confusions when seeing the ETA changes dramatically across different user interfaces. With many similar ETA models, it is very hard to ensure that they provide a coherent and consistent ETA estimates, and this further complicates the governance of the whole system. To address these three problems, DoorDash introduces multitask modeling, and this creates a unified model that can handle multiple ETA prediction tasks simultaneously. This approach allowed for shared learning across tasks, improve modeling efficiency, and ensure consistent and reliable ETA estimates across its user interfaces. At its core, the multitask architecture consists of a shared heavyweight foundation layer, followed by a specialized lightweight task head for each prediction use cases. Although there were challenges around more complex modeling training needs for this multitask architecture, because each model must simultaneously learn to predict different ETA use cases. The team can address this through sequential training different heads and achieve the best overall prediction performance. The third major modeling improvement was leveraging probabilistic models. Historically, the team's ETA predictions were only point estimates, meaning the model returns results like the ETA is 5 minutes or the ETA is 10 minutes. However, the accurate food delivery process is inherently uncertain and could be influenced by factors that are difficult to predict or out of control, which can impact the accuracy of any downstream business use cases. Imagine that for the components of ETA prediction, food preparation time, this could be impacted by the unknown factors like other orders out of DoorDash happening at the restaurants, resulting in delays in food readiness. Another example is that in dense urban areas, DoorDash drivers could have trouble finding parking. This can introduce uncertainties that could cause pickups or drop-off delays. To address this intrinsic challenge about uncertainty, the team leverages a two-layered structure that employs a probabilistic prediction model as a base layer, followed by downstream business use cases layers. This can ensure that the uncertainties are always predicted as the outcome of the base layer and properly utilized in downstream processes to enhance the decision-making and planning. With these three major improvements implemented in the new machine learning system, the team conducted experiments to evaluate the enhancements against the previous system. They measured the performance through two key metrics: the accuracy and consistency. Accuracy metric is the team's North Star metric. It measures how often a delivery arrives on time according to the prediction, reflecting the overall quality of the model's prediction. Consistency metric, which is the team's guardrail metric, ensures that the ETAs are stable and customers don't experience large fluctuations in their delivery times. With these two metrics, the team found results showing an 80% improvements in accuracy and 20% improvements in consistency, which is quite an impressive gain from these modeling improvements. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we discussed the importance of ETA for DoorDash and how the company enhanced its machine learning model through three key directions: upgrading from a tree-based model to a deep learning architecture, adopting a multitask modeling approach to share information across multiple ETA prediction cases, and leveraging probabilistic models to provide both point estimates and associated uncertainties. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.